purpose of this presentation is to give you a little bit of an overview about the utility network. The core product, or what we term the information model, is a collection of things. There's data schema that represents the different utility configurations. There are support applications in the framework of Pro or Web or Runtime, and there are things that work across both the data and the framework. So from a model perspective, we look at the utility network as a collection of domain-specific networks. So what do I mean by domain-specific networks? These are the commodities. These are your electric, your gas, your water, could be your telco, could be your rail. And common things about these networks include, a requirement to trace to be able to understand how things flow, and the ability to integrate that commodity network with a structure network. So for example, wires are structurally associated with poles. It's really important. That's an important concept in the utility network configuration. So there is a shared structure network that supports the one or more domain or commodity networks. So domain networks have some very common properties. They have a number of layers. There are actually 5 layers in total for a domain network. The first layer is a device. So the device represents the operational configuration. It's something that has a commodity value, some sort of cost value. It's either got a load value, or it consumes or meters a load, or it has the ability to operational connect or disconnect. The second category I'd like to talk about is a line. So a line represents the linear property along which the commodity flows. A junction is another point, just like a device, but it doesn't have operational properties. It just connects your lines. So it's not smart. It's not capable of doing anything. It's just there for connectivity. The next category is an assembly. So an assembly represents a collection of like equipment that does a single feature. So for example, if you think of an electrical switch, just like a switch in your house, it's a device that you can connect power, so when you flip the switch, the lights come on, or you could disconnect the power, so when you flip the switch in the off position, the lights go off. Well, in utility systems and electrical systems, sometimes these switches are arrayed in a bank or an assembly. So for electrical models, you may have 3 wires that represent one electrical line. And for those 3 wires, therefore, you have to have 3 switches. And those 3 switches are combined into a single bank assembly. We'll take a look at that shortly. And then finally is the subnet line. So that's the circuit or the feeder, or it's a logical representation of the devices, lines, junction assemblies, what they do, how they do, and how they serve the customer. We'll go into this a little bit more deeply. The next thing I'd like to cover is the structure network. So regardless of domain or commodity, regardless of whether it's electric, gas, or water, you're always going to have a structural network. And the structural network feature layers are always going to be junctions, lines, and boundaries. So for an electric, a junction could be a pole. If it's for a gas, it could be a frame or a platform to support the pipes. For a structure line, it could be a shield wire, a non-electrified wire that mechanically supports or mechanically protects the conductor. For pipes, it could be some sort of underground conduit. Could also be that for fiber as well. And then boundaries could represent facilities such as substations or pumping stations. It could represent smaller features, but it's always polygons. Okay? Now I'd like to move over to this utility network category. So the first thing in the utility network I'd like to get your attention to is something called a dirty area. So sometimes when you're seeing our videos, you may notice that these purple boxes show up. And that purple box represents an area where some sort of change to the network has occurred. And the user needs to validate to, one, make sure the change was correct in procedure and by logic and rules, but two, the user needs to update the network to make sure that the validation or the network tracing capability becomes updated as well. In addition to dirty areas, the utility network layer has the ability to identify point errors, line errors, and polygon errors. These errors represent specific features that are throwing back either some sort of validation restriction or some sort of connectivity behavior that's not enforced by a rule. And then the service territory is just the region of the network. So in the utility network, you can only edit features within the service territory. I think there's a 10% boundary, but you really want to be careful about that. I'd like to talk through the network diagrams just a little bit. Diagrams are basically schematic representations of geographic features. In a network diagram, you do have templates, and you have the diagrams itself. And then you'll notice up here we've got the rules, and the rules, both the network rules and attribute rules, and it's important to differentiate the two. Remember, a network rule pertains to the connectivity, the structural association, or the containment association. Attribute rules do things like calculate, constrain, or participate in the validation. And then the tiers and subnetworks, we'll get into that in other videos. So let's take a look at the utility network for an electric, gas, and water system. So we will begin with an electrical model. This model has both electric transmission and electric distribution. So looking through the table of contents, you see electric transmission, distribution, and our structural network. You will see a structural network in every example that we cover. Looking at the electric transmission network, remember devices, assemblies, junctions, and lines. So electrical transmission devices include things such as arresters. So an arrestor is an operational device that's designed to passively monitor surges. So if a power surge comes down the line or comes down a wire and it hits this arrestor, normally under normal operating temperatures, the arrestor acts as an insulator, so it's a barrier, electricity can't cross it. But because surges have higher than normal temperatures, the high temperature causes the arrestor to change from an insulator to a superconductor. And the power flow, the surge, the buildup of load will go down through the arrestor down to the ground. So an arrestor is an operational device. A relay is a type of switch. We have other switches. So remember, devices are things that open and close. So arresters, relays, switches, these things all open and close. Transformers, regulators, power factor correcting equipment, generation, storage, these things all have properties that provide load, that start load. They may or may not be controllers, but they establish load parameters. Then you have meters, which receive load parameters. So these things are all indicative of devices that either have some sort of operational capability. They can connect or disconnect or receive or change the flow of power. Now remember, assemblies are devices that are clusters of devices. So they are 3 arresters in a row or 3 switches in a row. So it's like a container. It's a point-based container, but these are really field position pieces of equipment that are designed to support your network. So if we come in here, let me go to the distribution network. So same thing, devices, assemblies, junctions, lines. So I'm going to take the assembly and bump it up a little bit. So these are transformer assemblies. And if I go into containment in that assembly, you could see all the features that are contained within that assembly. So if I were to look at the attribute table, we could see that that assembly, which is represented by this blue dashed outline, we could see that assembly contains connection points, fuses, and transformers. So an assembly is a container for a number of devices that represents a single operational facility on your system. Now, while I'm here, we're talking about containment as an association, and I mentioned this before, but let's look at the electrical associations. So if I were to turn on my associations, I can see the electrical connectivity properties, which I'm designating in red, of all the devices in this assembly. So you may be asking, why are you building these associations that don't necessarily show up? Well, it's a logical relationship. It's not a relationship, but it's a logical relationship between two features that is more performant than actually drawing a line. So we're keeping the connective properties without the cost of having to render a new line value. And I'll just go ahead and continue through with the distribution network here. So junctions represent those points. As you see here, it's called a connection point. It's just a reference point where lines can meet each other at a junction, but don't have to have an operational device to support it. One particularly interesting feature of electrical junctions are these things called risers. So some electrical wires are above ground, some are below ground. To go from above ground to below ground, you need a riser. And this riser is simply just the mechanism that takes the wire from underground to above ground or above ground to below ground for you to be able to connect an underground line to an above ground line. In the utility network, you need a riser. So this is an example of a edge junction edge network rule. So you could have an overground line as one edge, the junction is a riser, underground line is the other edge. And then you've got your line features, which represent your linear assets, your linear connective values. This network has two tiers. It has a low voltage tier and a medium voltage tier. And that's represented here in this line feature. And then finally the circuit. So this is what we call the subnetwork. Now if I were to zoom out a little bit, we could get properties of our circuit by identifying it and seeing really interesting things that are aggregated using network attributes. So we can count the number of customers and the total amount of electricity being consumed by those customers. We could calculate the length of all of the features in the circuit and even count the number of specific devices or the number of solar panels that are generating power for customers. So really interesting configurations. The structured network, regardless of domain type, is going to have junction. So these are all specific to either transmission or distribution electrical networks. They'll have lines such as trenches, ducts, and shield wire. And then your boundaries represent things for electric, such as vaults, cabinets, substations, or other facilities. Now, I briefly mentioned the utility network layer. So these error features represent things where connectivity may not be correctly configured. We either need a rule or we've got some sort of violation in place, or there's some sort of constraint, or even it could be that an attribute value is missing that enables the rule to fire. So we have errors and descriptions about what the area is for points, lines, and polygons. And then the dirty areas, remember, represent regions where an error or a new edit has occurred and your topology, your trace capability is out of sync. So that's what these dirty areas do. Now let's look at a gas network. So looking at a gas network, and this looks like this network is unconnected, but I could still go through the properties of the layer. So remember, we've got operational devices. So for a gas, that means valves, scrubbers, pressure changers, things that consume or transmit or modify load in any way, shape, or form. Assemblies are once again connective features where it could be an assembly of, or it could be a number of specific things that are all contained in a single point feature, just for clarity and user experience. Junctions, or you could see couplings and plugs and caps and ties and T's and things like that. And these are all non-smart features that just connect the pipes. We have the pipe types. So it looks like this is an interesting network. It's not just based upon pressure, which is, for the electric equivalency, it'd be based upon voltage. It's not just based upon pressure, but it looks like it's got some additional properties. So that means that this is probably a hierarchical network. So that means that the tiers can represent different things. They can represent pressure, it can represent cathodic protection zones, or it can represent configurations of the network. And then the lines represent the circuits. So this validates my theory that this has a hierarchical domain with multiple tiers that represent different configurations. So there's one configuration that represents a system, one represents pressure, one represents isolation zones, and then one represents the business. So really interesting configuration. Within the structure network, you still have lines, points, and polygons. For the lines, it looks like casing. You've got pipe casing. So that's kind of a protective shell around the pipes. You've got, for points, you've got supporting anchors and supports and hangers and vaults. And then for boundaries, you're going to have stations. You're going to have facilities, things like that. So in the water network, we have devices, assemblies, junctions, lines, and networks, just like we have in the gas. So devices can be filters or pumps or things that modify flow. Notice fire hydrants is a consumer point. Blow-off valves, meters, storage. So once again, all things that either collect or transmit, water flow. Assemblies are equipment collections that represent container locations. Junctions are just simple connection points, no operational capabilities. Lines represent the different types of pipes. So I'm inclined to believe that this is another hierarchical type of utility network because of the different types of configuration. So we got rectifier and bond cable, so that means it's probably cathodic protection zones. Transmission main and distribution main means there's some sort of business drivers. And then you've got the different types of services. So let's look at the networks. And we could see that there's a system network, a pressure network, an isolation network, and a DMA network. So yes, this is absolutely a hierarchical configuration with multiple tiers. Looking at the structural network, lines are once again just like gas, they're casings. So casings are protective coatings around pipes. The boundaries represent pump stations, vaults, storage. Once again, area facilities. And then the structured junctions represent supporting pieces of equipment. So regardless of your domain, the structure network and utility network properties or features are all going to be the same. The point errors, line errors, polygons, you're going to have that in every utility network. You're always going to have dirty areas, and you're always going to have the structural network configuration.